So let's answer this question that so many people keep asking me. What have I done? Or why haven't you done this before? Like they actually knew me for years. So let's go over the books I wrote, which you can see above, and some of my projects that I've worked on for quite so many years so you can get to know me. Beautiful. Okay, so we got the cord here and we got the light on. Let's bring this positive and negative. Let's hook the negative one and let's find that positive and hook up the positive. Okay, so we can see what that's going to say. Okay, so let's get a little bit of light on this other than what we got coming from the solar panels. Okay, so let's turn that on. And did something come loose here? Oh, I have it on the wrong setting. So there we have it. 17.35. It jumped up to 36, but 35 is good. 17. So we just say 17. Okay. So we have all that, and we know that 17 times 5. My brain is freezing up, so let's ask. Alexa, 17 times 5.
17 times 5 is 85.
So we got 85 watts if we use that circuit to make 1 amp to 5 amps. Now, that's more wattage, okay, than that the solar cell, this right here, is only a 20 watts. So that means that it puts out more than the solar panels when you add the proper amps with that boost. Okay. Now, since we have two, okay, so Alexa, 17 plus 17. Alexa, 17 plus 17.
17 plus 17 is 34.
34. Alexa, 34 times 5.
34 times 5 is 170.
170 is what this whole circuit, this one solar panel that we put, it's two solar panels, but we made one unit. That means, let's pick this up. That means that this unit, back and front, that means this top one here and this bottom right here is two solar cells. Okay? So that means we got 100 watts with that 5 amps. Okay? And look how it's small, a small area. So now I can do 2, 3, 4, which you've seen I had many of these. So that right by itself lets you know with those circuits that it is possible to run these solar panels on LEDs and get voltage out of it. And then we showed you techniques to get the amperage out of it. And it's way more than any of the power that you're going to use, because the battery charger changes 1 amp into 5 amps. And you can do as many as you want to do on there. And we have power, which we're going to take off of here. Now, we see we have positive and negative, and we have a DC motor. Let's see if I hook this up. Now, let's put a piece of tape on this. Let's take this off and actually put some tape on here so you can see it moving. Okay, we're back and we've gotten this on there, which should show us actual movement on there. So let's hook this up and see if we can get useful energy out of there. Now, we got useful energy running this, and you can see that's pretty fast. I don't think it's the full speed, but it's pretty fast. And we're using this right here. This solar cell is 17 volts. 17 volts and 26 milliamps of power. Okay, so let's begin there and talk about that. So the reason I showed you that is that these MOSFET circuits has a potential of giving current off of it, and it's called transient current. Okay, so I've worked with a lot of these designs, and the best one I've came up with so far is using this motor to actually turn this MOSFET on and off. That means we take the input of the solar to put power through here, but this turns it off and on by just rotating. Okay, so once we get this frequency from this motor on how fast it goes to turn off and on power to this MOSFET. This MOSFET is bigger than these three MOSFETs, I believe, but it will give you the amps needed, and you only need 5 amps. You get up to 20, you get way more than what you need to charge a battery, and from a single solar cell. So what solar panel. So what we wanted to show is that if it can actually run this motor, that means actually do work on the power you get from this solar panel, then the simple fact is we can amplify that with the circuits we've been working with. So again, this is going to be a switch for that, turning that off and on. So when I get this all hooked up, we'll be able to actually see this circuit working because it's going to be turning off and on at that speed. You hear that? At that speed. Okay. And let me explain this. This down here, this is a variable resistor. It's a word that starts with P, Picciano. I can never pronounce that right, but it's a variable resistor. I'll be able to control the speed of this motor. Okay. And that's what I want. I want to control this and the firing, the switching in there, if you will, in these MOSFETs to bring back the amps that we lost in this solar panel project and get amps back. That simple thing of getting the amps back means that I can take this, in which I'm getting from the equal flow that's next to me. That's what this is plugged into. Just unplug it. I'm taking that, and I know it's 24 watts of power, about 2 amps and 12 volts. Now, with that taken from the equal flow, I have to be, this has to produce more than 2 amps when I want to recharge the equal flow. And because this solar cell is separate, that means that the lights is individual, and that's the only thing running on this cord is the lights. But these two panels are separate. This is energy that's like separate from everything else. So it gives the appearance that when you put energy into this, turn it efficient. That's how the scientists say. We just say step up energy. Okay. But we turn it efficient. And the more efficient that you're able to get, then you can charge the equal flow. We're not saying that you're going to put more energy into it because you're just taking energy out of it, turning it efficient, and then you'll be able to charge the equal flow. Okay. And what that does is it's utilizing the extra energy that was wasted in the first place because it's being inefficient. But you're gonna get more surface area. That means two of these. If this is a 20 watt on top, on the bottom here is another 20 watts, and that surface R is actually generating electricity. So that means, let's count them: 1, 2 cords. Here's the other cord. Okay, so these 2 cords right here, normally you would have one, and we're going to use that to run the motor. This right here, we're going to actually use to boost something else, but we're putting all that energy back into the equal flow, and we're amplifying. So I just wanted to show that little setup, and I'm going to end that right here. Now that you've seen both Maxwell and my MOSFET circuit, which boost current, that means when you put it in a meter like that, it reads on the amps. Okay, so that's why you hear me say amps, even though that's incorrect. But we just wanted to show all the stuff that we worked with, the progress we made, and we're going to keep showing you more images so everybody understand this is not something we just started. It's been going on for quite a few years, before 2000, and then we got brave, and now we can show some of this, some of the equipment. Which you see, the blue boxes, is how I can put energy directly back into my house. Now let's go into some books that I've wrote. Okay, so you know the other videos that we covered many of this, so I don't really have to go into details, but you can see from the book covers that I've designed, we experiment with. These are the things that we write about. So you know, I'm just showing a few of our book covers so you understand that we've been doing this for a very long time, and I have actual published scientific papers, so we understand a lot. So this just gives you an idea on the projects we work on and the things we built, and some of the videos, like the one coming up, you see me actually make my own currency, flying cars. Now let's look at the unit in which I built this running my house. This is the full unit. It was a little bit too powerful, so we broke it down into pieces. And since there's solar that stacks like this and sits in your basement and run your house, we didn't need all of them. So what we end up doing is just buying the tie grids and breaking the units down. You'll see that coming up. We broke the unit down, and we only needed part of the unit to run the tie grids, because this thing in its full capacity will, if you see the voltage, blow up a tie grid. But we wanted to show that, and you've already seen the blue boxes, so you've seen the tie grids. And so we started making smaller units just to run single tie grids, which puts that energy directly back into the house. If you don't know what a tie grid is, please look it up and understand how they work. It's plug and play. It's very simple, and you don't have to have all that wires. And that's one thing I wanted everybody to know. We simplified the unit. It's not complicated. Okay, you've now seen this diagram, and we wanted to switch it so you can understand how we actually trigger this at high speeds using something Nikola Tesla did in his patent. So let's change this diagram over to the solar panels and the reed switch and show you how we use the motor, in which you just seen, to turn it on at high speeds. Okay, you now got a diagram. You see the reed switch. If people don't know what that is, please look that up. And you see the solar panel, and you see the motor, which will have magnets on it, which you've seen in the last videos. It spins this, it turns that switch on and off at high speeds. Now, we got useful energy running this, and you can see that's pretty fast. I don't think it's the full speed, but it's pretty fast. And we're using this right here. This solar cell is 17 volts. 17 volts and 26 milliamps of power. Okay, so let's begin there and talk about that. So the reason I showed you that is that these MOSFET circuits has a potential of giving current off of it, and it's called transient current. Okay, so I've worked with a lot of these designs, and the best one I've came up with so far is using this motor to actually turn this MOSFET on and off. That means we take the input of the solar to put power through here, but this turns it off and on by just rotating. Okay, so once we get this frequency from this motor on how fast it goes to turn off and on power to this MOSFET. This MOSFET is bigger than these three MOSFETs, I believe, but it will give you the amps needed, and you only need 5 amps. You get up to 20, you get way more than what you need to charge a battery, and from a single solar cell. So what solar panel. So what we wanted to show is that if it can actually run this motor, that means actually do work on the power you get from this solar panel, then the simple fact is we can amplify that with the circuits we've been working with. So again, this is going to be a switch for that, turning that off and on. So when I get this all hooked up, we'll be able to actually see this circuit work.
This coil, we're only using the top one here. We're not using the bottom ones. We're just using this. The 336961. And we just have a Schottky diode coming off here. Schottky. Good. And for some reason, I was able to reduce my transistor to just one DC 337B, and I tuned the resistance down so the circuit consumes 15 milliamps at 69 volts DC, pushing that transistor harder than it should for the switching. But the concept of this system is abrupt DC switching, not excessive current consumption in the transmitter. You want abrupt excessive switching to give you those fantastic resonant effects and the range.
So all the stress that you people have accused me of, I had to go get my feet rubbed by a very beautiful woman in Laos just to relax. But you have all the information you need, okay? You've seen all the diagrams. You've seen other people say we done the same thing. This technology has been around for quite some time, and you see that I run my house on the projects that I created with my solar, which I think is a more stable, more simple way to run this type of product. It's just not as complicated, and it doesn't overtax the MOSFETs. So it's so much more information. I'm just a librarian. I just give you information. I tell you how the components work, and that's my job. But everybody else wants to say that I'm trying to put this black inventor down. No, that's not my job. I'm not putting him down. I'm just confirming that MOSFETs do what they do. Thank you.